Hello everyone, and welcome to Apache Spark series. Myself Sangam Chabe, and in previous lectures we understood about what is a Spark, what are RDD, and in last lecture we understood how to read external datasets. And in this one we will have to understand what are transformation, lazy evaluation, and actions. So these are the contents of our today's lecture: RDD operations, transformation, lazy evaluation, and actions. So let us start. RDD supports two operation: transformation and actions. So before going into transformation and actions in detail, we just need to understand why we are learning transformation and action. So whenever we are working on Spark, we have to come across a different type of operation every time we are working on a file or we are doing any operations. So it's very important that we should understand these two things: transformation and actions, because in the terms of performance, in the terms of efficiency, these two operations play a major role. Because when we are working on a smaller set of data, let us suppose we are working on a single node cluster and we are doing for our learning purpose, it hardly matters, it does not matter a lot. But when you are working on a group of cluster, when you are working on a real time project, it is very important that we should apply proper transformation and actions. And we should, it's not only we should apply it, we should apply it in a proper place also. And where to apply a transformation, where not to apply a transformation, similarly the same thing for action also. That is why these two operations are very important, because I have seen many project where the flow are good, everything is in line and everything coding standards are fine, but due to the application of transformation and actions in incorrect places, there will be a performance pitfalls, and efficiency reduces to a larger extent. To understand this concept, we need to go through transformation as well as action. Transformations create a new dataset from an existing one, and each transformation creates a new RDT and does not affect the current RDT. First of all, we need to understand that if we apply any transformation, it will create another transformation. So the second transformation, it's coming from the first transformation. And the second thing is that whenever we apply any transformation, it creates a new RDD and does not affect the current RDD. We already know that RDD are immutable, so whenever we do a transformation, it will create a new RDD. So the first, let us suppose that the first RDD is a parent one and the second one is a child one. So whenever we put any transformation, we will create another RDD. So the first one is parent one, and the RDD that is created after transformation is the child one. Spark keeps tracks of the set of dependencies between different RDDs called the lineage graph. Lineage graph is very important. So lineage graph, in the sense, suppose first of all we try to understand what do you mean by lineage. Lineage is like can be our family lineage also, like grandfather, father, and son. So this complete chain is, we can also say it's a lineage. So from son we can come to know the father, and from father the grandfather, or vice versa also, from grandfather to father and the son. So this way we can keep track of all the family chain. Similarly, in the Spark also we can keep a complete track of the dependency between the different RDDs using lineage graph. It uses this information to compute each RDD on demand and to recover lost data if part of a persistent RDD is lost. So when we are started to learn RDD, the first thing I have told you that RDD means resilient distributed data set, and I have told you many fancy word like it's fault tolerance and we can recover. So how does it recover? It the information to compute each RDD on demand and recover lost data if part of persistent RDD is lost. So through the lineage graph, we can come to know where an RDD is lost and how to recover this lost RDD. So I think that is quite clear that lineage graph will helps to understand and keep tracks of all the dependency between different RDDs, and in case something is lost in between, we can keep track of it. Transformation are lazily evaluated, that is, they are not executed immediately unless an action is called. When a transformation is invoked, Spark makes a note of this in metadata, and all the transformations are performed once an action is called. So whenever we are making any transformation, it gets written in the metadata, and all the transformation are performed once an action is called. So the transformation is like transformation are the things that do everything, means it keeps it changes the data, but it does not create the final output, and the actions are the things that creates the final output. We'll understand action later, but for the timing I just want to make you understand that transformation never generate the final output, it's always the actions. So whenever we have a transformation, Spark keeps making a note of this in metadata, and all the transformation are performed once an action is called. And to keep track of this all thing and performs once when an action is called, Spark uses a concept called lazy evaluation. So we will try to understand. Suppose from New Delhi I need to go to London, and then I need to go to Dubai, and imagine I don't know the complete my tour plan. So what will I do? And suppose my final destination is UAE, and I'm not sure initially. So what I have to do, I will take a flight from New Delhi and I will reach to London. Once I reach London, then I come to know, okay, I have to go to Dubai. So I will take a flight and I will go back to Dubai. So if you say from New Delhi to London, it's a 10-hour flight, and from London to Dubai, it's a 6-hour flight. So it's total 16 hours. Okay. But suppose I know all the complete process that I have to go to Dubai. So why should I go to London? I will directly take a flight and go to London. So it's a 3.5-hour journey probably. So this will reduces our you can say it makes us efficient, where in our first approach we are putting almost 16 hours. In the second approach we are achieving this in 3.5 hours. So this is the work of lazy evaluation in Spark. All the transforms are lazy evaluated due to this very reason. Lazy evaluation means evaluating something only when a computation is really needed to be done. It does not evaluate every transformation. We should take note of this word. It does not evaluate every transformation just as it encounters it, but instead waits for an action to be called. Once an action has been called, it will just do all the transformation queued up until that point at once and in one go. So Spark waits for all the transformation, waits for the action, and once an action is met, it will do all the transformation in a single shot. This is desirable than evaluating each transformation one by one, because when you wait till the end, you have the whole DAG. DAG is directed acyclic graph. We will understand this in our upcoming lecture, but for the time being, just try to understand that it's a kind of edge and vertices kind of stuff graph, and it will create the complete picture of how the Spark jobs will be will be executed. So when you know the complete graph, you can have a different way to achieve it. You can find a shortest path also. So in this process, lazy evaluation plays an very important role. It will actually reduce the number of steps. It will improve the performance. These are one of the main advantage of lazy evaluation. So let us take an example. Consider a log file log.txt and of size of 1 GB, and we need to fetch the first row which is having error. So we need to find the first row from log.txt which is having an error. So what will we do? In our last lecture we understood we will read the file and create an RDD and filter the RDD with error as condition, okay, and take out the first error. RDD for it's a very simple process, 3 or 4 lines of codes, that's it, okay. But the way of computation, the way Spark approaches for this problem is different than other processes. Spark will here optimize the processing of the log file by stopping as soon as it finds the first occurrence of an error message in any of the partition. So suppose I have 1 GB of data and it has been distributed across 50 partition. So it will go and check the first partition, and wherever it finds the first partition, first error message, sorry, it will display it, because it will follow the lazy evaluation concept, and we have to take RDD dot first. So why should it go and check all the partition? Okay, it will just see the first occurrence of the error message and display the data. That's it. Suppose if we are doing in a different process, because we have to evaluate our process, we need to compare what was earlier and what is the newer one. We should try to understand it. If the same scenario had been repeated in eager evaluation, Spark would have filtered all the partition of the log file even though you were only interested in the first error message. So what Spark will do, it will keep on checking all the partition, take out the result, and then display the first message. So suppose if this is a 1 GB file or 100 GB of file, how many partition will get created, how much time it will take to filter it out, and how much time it will take to produce the result. But in the first approach, it will just check the first partition and got the result. Suppose it's not available in the first partition, it will go for the second one and find the result. So for a one occurrence of line, we are consuming this much of time in the second approach. That is the eager evaluation. But in the lazy evaluation, we are finding it in a very short time. So what is narrow transformation, wide transformation? Because transformation are divided in two main parts. One is narrow transformation, another is wide transformation. In narrow transformation, all the elements that are required to compute the records in single partition lives in the single partition of parent RDD. This line is very important. The records in single partition lives in the single partition of parent RDD. A limited subset of partition is used to calculate the result, and some of the example of narrow transformation are map and filter. So in narrow transformation, whatever the data you try to compute, suppose in our previous example we are filtering out the data on the basis of error message. So all the whatever we imply any narrow transformation like map and filter, it will check data in that single partition. Okay, it will check data in that single partition and filter out from the partition in which we have the data. And is an output RDD has partition with records that originate from a single partition in the parent RDD. Only a limited subset of partition used to calculate the result. So we have a limited set of partition that that narrow transformation do in on the single partition. Okay, so it's you can say the scope of narrow transformation is confined to only one partition. Okay, and examples of narrow transformation are map, filter, etc. Spark groups narrow transformation as a stage which is called pipelining. About the pipelining, once we will understand DAG, we will see. But for the time being, just understand that all the narrow transformation are grouped in a single stage, and that is called pipeline. What is wide transformation then? All the elements that are required to compute the records in single partition may live in many partition of parent identity, group by key, reduced by key. So whatever the computation you try to achieve, it's not that they are available in the single partition. There is chance that they are available in multiple number of partitions. But in the narrow transformation, it's available in the single partition. But in wide transformation, it can be available in the multiple partition. So this is the difference between wide transformation and narrow transformation. In narrow transformation, we have the data in the single partition, but in wide transformation, we can have data in many partition. Suppose in our previous example of the error one, suppose I have to do some group by operation. What does it do? Then it has to compute, go and check each and every partition and compute it and do the group by, because it has to take care of all complete data. It can't do from single the data that is available in a single partition. All of the tuples with the same key must end up in the same partition processed by the same task. To satisfy this operation, Spark must execute RDD shuffle. We transfer data across cluster and result in a new stage with a new set of partition. So once we use a wide transformation, it will create a new stage. Once we will go through DAG, we will come to know how does it create a new stage and creates the data in a new set of partition. This is the work of wide transformation. Now the second RDD operation, actions. Actions, we already know that is the second type of RDD operation. They are the operation that return a final value to the driver program or write data to an external storage system. So the final output stuff, result stuff is done by, taken care by action. Action forces the evaluation of the transformation required for the RDD. They are called on since they are required to actually produce output. So whenever we called an RDD, we called an action on an RDD, it will create the final result. And some of the example of action are reduce, collect, save as text file, take, first. So it will finally produce action, always produce an result or help in storage, external storage system. So these are things about RDD operation. If you like the video, please like and subscribe my channel. It will be very important and encouraging to make me more videos on this topic. And if you want to learn any specific thing related to Spark, big data or Python, kindly write it in the comment box, or if you have any doubt, I will try to clarify it. So thank you everyone. Thanks for watching this video. Please like and subscribe my channel. Thank you. Bye bye.